You know, my old grandpa always used to say, always use the right tool for the job. Well, ain't nobody got time for that. I say, use whatever works. Right tool for the job. Okay, Boomer.
Howdy folks, Ed here. Welcome back to Bullnose Garage, and don't be that guy. If you've ever tried removing a harmonic balancer with a chisel or peeling off a gasket with a butter knife, you're in the right place. Today, we're talking about the real tools that you need to break an engine down and put it back together without breaking your knuckles or your spirit. Sure, buying the right stuff might cost a bit more up front, but trust me, it'll save your hairline and your sanity in the long run. So stick around, and by the end of this video, you'll have a rock-solid grasp of which tools truly matter, which ones you could probably live without, and which ones belong in the hands of a professional machine shop. Oh, sorry, the anemometer and rubber chickens are for a distant video.
Hello.
All right, let's get right into it with a couple of the big and obvious ones. First off, the engine hoist. Few sites say engine teardown like a V8 or inline 6, dangling midair on a sturdy chain in your garage. If you're pulling the block out of your car or truck, this tool is a no-brainer. Perfect 10 out of 10 on the must-have scale. Some call it a cherry picker, but whatever you decide to call it, it's all about heavy lifting without wrecking your back or your garage floor. Basic models run between $100 and $150, great for lighter engines or occasional use. For larger engines or frequent jobs, heavy-duty hydraulic hoists cost $200 to $400. Brands like Torin or this Pittsburgh here from Harbor Freight offer reliable options that balance quality and price. You know, mechanics once rigged rope and pulley setups in barn rafters for engine lifts. Thankfully, we got hydraulics on our side today. Just make sure your hoist has the capacity for your engine and your lifting points are solid. Nobody wants a swan diving engine mid teardown. Look for features like adjustable booms and stainless steel hooks. They make teardown smoother and safer. Additionally, a $40 load leveler is a must for big lifts. Also consider portability. Wheeled or folding booms make storage much easier. Prices vary with these features, so think about what you need most in your setup before you buy. Next up, the engine stand. Once your engine's hoisted, you need a solid perch to tear it down. An engine stand is like a mechanical easel, letting you rotate the block to access every single nook and cranny. This gets a 9 out of 10. It's crucial for a rebuild. After all, you're not holding that block in your lap. Basic engine stands run between $50 and $100, fine for lighter engines or tight budgets. For bigger blocks or frequent use, heavy-duty models range from $150 to $250. A folding 4-point stand, like this $200 Pittsburgh model here, beats a 3-point design for stability and folds for easier storage. Engine stands offer various mounting patterns or even adjustable mounts, like this one, to fit different blocks. Match the stand to your engine's mounting points to avoid compatibility issues. Look for features like adjustable clamps, 360-degree rotation, and foldable bases to keep things stable while you work. One common mistake with engine stands is mismatching your stand to your engine's weight or mounting pattern. A flimsy stand risks an expensive, painful mess. Check your weight capacity and compatibility before buying, and also ensure that the stand is balanced and secure to avoid accidents during a rebuild. All right, next up, we have a Silicone Tool Tray Set. Now, this might not be the flashiest tool, but it's key for keeping nuts, bolts, and tiny doodads organized during a teardown. It's a 5 out of 10, not critical, but it'll save you headaches and time hunting for that elusive bolt. Basic sets run from $15 to $30, great for smaller projects, and for more compartments and better heat resistance, expect to spend $40 to $60. Silicone trays offer flexibility, non-slip grip, and easy cleaning. Just rinse them off and they're ready for the next job. They stay put wherever you put them, whether it's on a cold engine block or something warmer. Alternatives like magnetic work trays are okay for ferrous hardware, and even a plastic lunch container can do it a pinch, but silicone trays win. They're heat resistant and won't scratch painted surfaces. They handle extreme heat, so if you accidentally set it on a really hot manifold, you don't have to worry about it. And bonus, they double as pet food bowls. Just make sure you wash them first. Next up is an oil drip mat or tray. It's an unsung hero for keeping your garage oil slick free. It's a 4 out of 10. You can skip it if you're outside or you don't mind a mess. But in a proper garage setup, it's really a sanity saver, and it might even save your relationship. Oil drip mats come in various sizes and materials. Basic rubber or PVC mats are between $20 and $40, while heavy-duty options like bigger trays or ones that have raised edges or layer designs cost between $50 or $100. Cheaper mats may not last with frequent heavy spills, so spending more upfront on a quality mat can save money and hassle long-term. Pros use similar mats or large drip pans to stay tidy and safe. A clean floor not only looks better, but prevents slips and trips. An organized workspace makes teardowns more efficient. Focus on the job, not the mess. Next up is a Harmonic Balancer Puller. For a full engine teardown, you'll likely need it to remove the balancer and excess timing components. This tool gets a 7 out of 10. A 3-jaw puller can work in a pinch, but a dedicated balancer puller saves you hassle and prevents damage. It also works as a steering wheel puller and handles some other automotive pulleys. The Harmonic Balancer absorbs engine vibrations, its critical role. Early engineers found crankshafts without dampers often snapped under stress, causing catastrophic failure, so it's not just a fancy pulley. It keeps your engine smooth and quiet. Balancer pullers like this one range from $30 to $80 depending on the quality and the included adapters. Basic sets suit smaller engines or occasional use, while comprehensive kits with multiple adapters can top $100 sometimes. A 3-jaw puller works at a pinch, like I said, but it risks cracking or warping the balancer. If you're doing multiple rebuilds or tackling different engines, invest in a dedicated puller and never use a chisel. And speaking of 3-jaw pullers, that's next on our list. While a Harmonic Balancer Puller is job-specific, a 3-jaw puller is a versatile go-to for tasks like pulling stubborn pulleys, gears, or even steering racks. This gets a 5 out of 10. It's not critical for an engine rebuild if you've got specialized tools especially, but it is a handy backup for unexpected tasks. 3-jaw pullers start between $15 and $30. More durable models with better grips and higher capacity can run between $40 and $80. The 3-jaw puller has a long legacy. Blacksmiths and millwrights used similar designs on steam engines, making you part of a centuries-old tradition. Slipping or marring surfaces is a common issue if the jaws aren't aligned, so ensure a firm, even grip before cranking and use penetrating oil to loosen stubborn parts. Patience is key. Rushing risks damage. Next up is a carbide scraper. When stripping gasket sealants or stubborn carbon, this tool is your best friend. This gets a 6 out of 10. Big upgrade from the chisel and butter knife days. Not essential for occasional maintenance, but for serious rebuilds, it saves frustration and ensures precision. Carbide scrapers come in various shapes and sizes. Basic handheld models like this one here run between $10 and $20. For heavy-duty jobs, multi-tool scrapers or sets with versatile blade shapes cost between $25 and $50. These tools are incredibly durable, staying sharp for longer than steel. Less sharpening, more working. Some models even offer replaceable blades, saving you from buying new tools. Carbide's toughness and heat resistance make it a go-to for industrial metal lathes. If it handles that stress, baked-on gaskets, that's no problem. Scraping too aggressively with a carbide scraper can gouge metal surfaces, so use a light touch, keep a consistent angle, and make gentle passes to avoid damage. Meet Plastic Gauge, a simple but vital tool for engine assembly. When rebuilding an engine, checking bearing clearances is critical for longevity and smooth operation. Plastic Gauge, or Plastic Gauge, makes it easy. Place a waxy strip between the bearing and the journal, torque down to spec, and measure the squished strip to check clearance. This earns an 8 out of 10. Accurate bearing clearance is non-negotiable for a reliable engine build. Plastic gauge is simple, but it comes in variations. Different colors measure specific tolerances. Green and red are most useful for most builds. Packs of single-use strips cost between $10 to $20 and last several projects, while larger kits range from $25 to $40. Plastic gauge is simple to use, just place, torque, and measure. But for accurate results, ensure both surfaces are spotless, as dirt or debris can skew your measurements. Remember, plastic gauge is single use, so handle it carefully to avoid waste. Since the 40s, plastic gauge has revolutionized bearing clearance checks. Before it, mechanics relied on cumbersome, less accurate methods. This simple strip brought precision to hobbyists and pros alike. One common mistake with this stuff is just taking inaccurate measurements. Follow the instructions. Apply the strip evenly, torque to spec, and measure precisely. Rushing can lead to misleading readings and compromise engine performance. Next up is a set of feeler gauges. Whether you're setting valve lash, checking spark plug gaps, or verifying type tolerances, this tool is a must-have. This gets a 7 out of 10. It's not an everyday tool, but crucial for precise measurements that ensure engine performance and longevity. A good set prevents misfires and uneven wear. Basic sets with 10 to 20 strips cost between $10 and $25. It's great for hobbyists. Larger sets with 50 plus strips or digital options range from $30 to $60. Slip gauges date back to the late 1800s, but car enthusiasts adopted them for spark plugs and valve clearance checks. Quality feeler gauges are precise and durable. Stainless or high carbon steel resists bending and wear. Some advanced sets include color coding or label thicknesses for a quicker selection. A common pitfall with these is bending them or mixing up the strips. Dirty or warped gauges can lead to incorrect measurements and engine issues. So, handle them carefully, store them properly, and inspect each strip before you use it. Next up, we have a dial bore gauge. For serious engine rebuilders, it's essential for measuring the cylinder or bearing bores accurately. This earns a 9 out of 10. Skipping it risks building an engine with out-of-spec cylinders, leading to poor compression or excessive wear. Precision here is the difference between reliable performance and constant headaches. Dial indicators trace back to 19th century clockmaking, where precision tools for watch gears found a new life measuring engine cylinders. Dial bore gauges come in various styles. Basic single dial models run between $40 to $100, and for more versatility, dual dial or digital gauges can cost between $100 and $200. Advanced models feature adjustable bases and magnified dials for easier reading in tight spaces. Calibration kits ensure accuracy over multiple projects, and compact designs with protective cases add portability and durability. Calibration with these is a common pitfall. Always zero the gauge with a known standard before you use it, and measure straight across the bore, not at an angle, to avoid distorted readings. Clean and store the gauge properly to maintain accuracy and extend its life. Next up, straight edge. For checking warpage on cylinder heads or deck surfaces, this tool is indispensable. This one earns a 6 out of 10. It's not as critical as an engine hoist or a torque wrench, but it's essential for ensuring flat components and a smooth rebuild. Aluminum straight edges, like this one here, are lightweight, rust resistant, and less fatiguing for frequent use. They're ideal for tight spaces. They're also cheaper, but they can dent or scratch more easily, which can affect the precision. Aluminum's lower rigidity may limit its accuracy for really precise measurements. Steel straight edges are rigid and durable, perfect for precise measurements and larger components where even very slight warping matters. However, they're much heavier, they're harder to handle in tight spaces, and they're prone to rust if you don't maintain them right. Prices for these vary. Aluminum straight edges run between $10 and $60, while steel models cost between $15 and $60. Dropping or dinging a straight edge, especially steel ones, can ruin their precision. So make sure you handle them carefully, keep them clean to avoid false readings, and store them properly. Look for smooth edges, precise markings, and protective coatings to ensure accuracy and durability. The pros use granite slabs for unparalleled accuracy, but for us mere mortals, a straight edge is going to work just fine. Next up, we've got a magnetic-based dial indicator. This tool is a must for serious rebuilders, measuring crankshaft end play, camshaft runout, and other precise movements. It earns a 6 out of 10. It's not as critical as an engine hoist or a torque wrench, but it's vital for precise component movement. The magnetic base keeps the dial indicator steady, letting you move components and measure without constant repositioning. Basic models like this one here cost between $30 to $60, while more precise, durable options can run between $70 to $150. One thing you want to look for is making sure that you secure the base on a clean surface to always get a good accurate reading. Always clean and degrease everything first. Also, like with bore gauges, you got to zero the gauge before you start measuring. Next, we've got a vacuum pressure gauge kit. Now, this kit is an essential for a basic teardown, but it's invaluable for diagnosing leaks or checking seals post-rebuild. This earns a 5 out of 10. It's not a must for every rebuild, but it can save you from frustrating troubleshooting by measuring vacuum levels accurately. Basic kits like this one with a single gauge and just some adapters cost between $20 and $40. It's great for beginners or tight budgets. Comprehensive kits with multiple gauges, adapters, and digital displays can range from $50 to $100. A good vacuum gauge kit detects leaks and verifies engine seal integrity. Accessories like hoses and fittings make connecting to engine ports much easier. Folks that are new to this can feel overwhelmed by all the readings. So you learn your engine's normal vacuum range before testing. This helps spot leaks or deviations quickly. Next up is a vacuum leak down tester. Now, this isn't the same thing as a vacuum pressure gauge kit, but it is a cousin. It's indispensable for deep engine diagnostics post-rebuild. This earns a 7 out of 10. Not an everyday tool, but is crucial for checking valves, piston rings, and cylinder seals to ensure smooth, efficient operation. Vacuum leak down tests originated in aviation, where pilots tested for even the smallest leaks to ensure engine reliability at altitude. This precision approach eventually found its way into automotive diagnostics, and that enhances engine rebuild reliability. Kits like this generally go between $50 and $100, and advanced kits with more digital readouts or fancy test ports run between $150 to $300. Look for models with digital displays for easier reading and multiple adapters for various different types of engines. Advanced kits with built-in pumps or integrated gauges can streamline testing. Ensure your compressor provides consistent pressure. Weak compressors can skew the readings and the diagnostics. Next up is a mini spring tester. First-time builders might overlook this tool, but it's handy for spotting weak or mismatched valve springs. This earns a 4 out of 10. It's not essential for every rebuild, but measuring seat and open pressure offers insights into your valve train's balance and prevents valve float, especially at high RPMs. Mini spring testers are straightforward and affordable. Drag racers often test and swap valve springs mid-season to prevent valve float and push their engines to the limit. This cheap insurance enhances performance and extends engine life by keeping the valve train balanced under extreme conditions. Common issues with these include incorrect setup or measuring at the wrong heights, which can skew your results. Follow the manufacturer's instructions carefully and measure precisely. If you're working with a brand new matched set of springs, then you might not need this tool, since brand new matched sets of springs are supposed to be matched and designed to work together harmoniously right out of the box. But it might be worth checking them anyway, especially if you've got a few $1,000s going into your build. It's kind of cheap insurance. Next up, valve spring compressor. This tool is crucial for removing and installing valve springs during a teardown or a rebuild. This earns an 8 out of 10. While it's not as universally essential as an engine hoist or a torque wrench, it's indispensable for safely handling valve springs. C-clamp style compressors like this one are widely available. Basic models cost between $20 and $40. It's great for smaller engines or occasional use. For larger engines or frequent jobs, robust models priced $50 to $80 offer better durability and ease of use. These tools adapt to various spring sizes, but maneuvering in tight cylinder head pockets can be tricky. Shade tree mechanics once use sockets and clamps to compress springs. It's cumbersome and way less safe. Modern C-clamp compressors are safer, more efficient, and prevent parts from flying across your garage. A common issue with these is slipping off the retainer, which can send keepers flying. So always secure the compressor properly before you tighten it down, and apply gradual pressure to avoid slip-ups. Next up is a piston ring filer. For engines with new rings, this tool is essential for ensuring everything is up to spec. This earns a 7 out of 10, not a top priority, but precise end gap filing significantly boosts engine performance and longevity. Basic handheld models like this one here cost between $10 and $25. More durable models with adjustable features for different ring sizes can run between $30 and $60. Choose a model with a stable grip for consistent, accurate filing. A built-in gauge sometimes can help verify the end gap as you work, avoiding constant stops to measure. Hand filing rings with a small file used to mean guessing angles and hoping for the best. Well, you can still do that. I'd recommend against it. Precision piston ring filers eliminate the guesswork, improving reliability, performance, and consistency in modern engine builds. Avoid removing too much material or filing at the wrong angle, which can harm compression and increase wear. File gradually, measure frequently, and maintain consistency to prevent uneven gaps. Up next, piston ring pliers. Ever snapped a ring trying to do it by hand? Piston ring pliers prevent that heartbreak. This earns a 6 out of 10. It's not as critical as an engine hoist or torque wrench, but it does make installing piston rings smoother and less stressful. Piston ring pliers haven't changed much in decades. They still use the same scissor action as they kind of always have. Basic manual models can cost between $10 and $20, while more robust options with adjustable jaws or locking mechanisms can range from $25 to $40. Advanced pliers with locking mechanisms maintain expansion without manual pressure, which makes multiple ring installations easier and less tiring. Avoid yanking too hard, especially if you're new to the tool. Overzealous handling can bend or crack rings, which causes delays and engine issues. Let the pliers do the work. Apply steady pressure and stay within the ring's natural flex. Take your time to ensure each ring is installed correctly. Up next, we have a ring compressor, specifically the band style type, popular among engine builders. This earns an 8 out of 10. It's essential for safely installing piston rings without damaging them or the cylinder walls. Ring compressors come in two types, basically. You got the band style, and then there's a tapered sleeve. These band style compressors are universal and versatile, and they cost between $15 and $40. Tapered sleeves, which are favored in speed and race shops, are more specialized, and they cost between $50 and $100 or more. Tapered compressors are common in race shops for speed, but adjustable band compressors are the go-to for enthusiasts. Their flexibility suits various engine types, making high-quality rebuilding accessible to just about everybody. Band-style compressors clamp around the piston, letting you gently tap it into the bore while protecting the rings. Look for adjustable bands, secure locking mechanisms, and features like protective coatings or rubber grips to prevent cylinder wall scratches. One common mistake with these is not snugging the compressor enough, which can cause a ring to pop out and scratch a cylinder wall. That's a bad day. Secure the compressor tightly, double-check the ring orientation, and use steady taps to maintain control. Precision and patience are key to a successful installation. Next up is a torque wrench, easily one of the most essential tools in your engine rebuild arsenal. I'm giving this a perfect 10 out of 10 because tightening fasteners to the proper specs is critical for engine integrity and performance. Whether you're working on rod bolts, main caps, or cylinder heads, a reliable torque wrench ensures precision and prevents catastrophic failures. There are a few different types to consider, each with its own strengths. Beam torque wrenches are simple, affordable, and durable. They use a pointer and a scale to show torque, but they require careful reading and can be less precise at higher levels. Click wrenches, like this one here, are popular because they're accurate and easy to use. You'll hear a distinct click when you hit the right torque, so there's no need to keep an eye on the scale. Digital torque wrenches go a step further with features like LCD displays, memory storage, and even Bluetooth tracking. They're precise and convenient, making them a favorite if you want tech in your toolbox. Finally, my personal favorite, split beam wrenches combine the durability of beam wrenches with the accuracy of a click wrench. They're built to handle heavy use, making them perfect for serious rebuilders. Pricing varies depending on the type. Beam wrenches are the most budget-friendly at $15 to $40. Click wrenches run between $30 to $100, while digital wrenches start at $70 and can exceed $200 each. Split beam wrenches typically cost $50 to $150 and offer excellent durability and precision. When choosing a torque wrench, accuracy and reliability are key. One thing to avoid is using your torque wrench as a breaker bar. It's a surefire way to damage the internal mechanism, and don't skip calibration. Frequent use can throw off accuracy, so calibrate it regularly and store it appropriately in its case. A well-maintained torque wrench is a tool you can trust for years, and your engine will thank you for it. And next, we have a torque angle gauge, a tool essential for torque-to-yield bolts that need precise torque and angle measurements. This earns a 7 out of 10. Not an everyday tool, but crucial for ensuring engine integrity and longevity with torque-to-yield fasteners. Modern engines, especially those with aluminum cylinder heads like the high-performance kind, rely on torque-to-yield fasteners for uniform clamping forces and effective sealing. A torque angle gauge ensures precise tightening, preventing gasket blowouts and boosting engine reliability and performance. A basic torque angle gauge like this one here is $20 to $40. They provide simple, easy-to-read measurements. Advanced models, priced $50 to $100, may include digital displays, memory functions, and locking mechanisms for added precision and durability. Misalignment is a common issue with torque angle gauges, and it leads to inaccurate readings and improper tightening. So to avoid this, make sure you keep the gauge secure and aligned and read the instructions carefully. Practice on a few bolts before working on critical components. Next up, assembly lube. Think of it as the icing on your engine's cake, but instead of just making things look good, it prevents metal-on-metal contact during that critical first startup. This earns an 8 out of 10. It's not a daily tool, but it's essential for smooth engine break-in and long-term reliability. Assembly lube provides a protective coating during startup before that sweet, sweet engine oil takes over. It prevents wear when components are most vulnerable without attracting excess dirt or debris. Basic assembly lube costs $5 to $15, making it an affordable insurance policy. Premium formulations for high-performance engines can run $15 to $25 and offer a little bit of enhanced protection. Early racers used to use gear oil or even STP additives to makeshift assembly lubes, but they lack the protection of modern blends like this Permatex Ultra Slick here. Today's lubes are engineered for optimal engine break-in and enhanced performance and reliability without the guesswork. Common mistakes include using too much or too little of this stuff. Excess lube can attract dirt and cause sludge, while too little, it leads to more friction and wear. So apply a thin, consistent layer and avoid mixing this with other lubricants that can reduce the effectiveness of it. Just follow the directions and ensure proper application. Up next, we have thread sealant with PTFE. This is for threaded fittings that might leak oil or coolant. Thread sealant, in those cases, is your best friend. This earns a 6 out of 10. It's not as frequently used as other tools, but it's invaluable for leak-free connections. PTFE, which is the same material that makes nonstick pans slippery, it creates a reliable barrier against leaks while allowing components to be easily disassembled. Standard tube of this stuff is between $5 and $10, making it an affordable addition to your toolkit. PTFE particles provide excellent sealing without clamping, and they resist oil, coolant, transmission fluids, that kind of stuff. Its non-hardening formula ensures easy disassembly during maintenance too. Avoid using thread sealant on sensors or plastic fittings where it's not recommended. Over-application can cause excess to squeeze out, which potentially clogs passages, so watch that. Clean and dry threads before applying a very thin, even layer to all the male threads. Assemble by hand to ensure proper engagement before tightening, and always check the manufacturer's guidelines for proper compatibility. So that covers all the tools I'll be using during my rebuild, but there are a few other tools you might want to consider depending on the nature of your build or how much of your own work you want to do. You might want to consider a ridge reamer, designed to remove the ridge that forms the top of the cylinder over time. If you're refreshing an engine and reusing the bore size, a ridge reamer is essential for shaving the ridge and safely removing pistons. However, if you're sending the engine to a machine shop for an overbore or any other work, they can handle this step. It makes the ridge reamer optional for DIY enthusiasts. Basic ridge reamers cost between $20 and $50, accessible for hobbyists, while precision models for specialized applications range from $50 to $100. A good ridge reamer provides a smooth, consistent finish without removing excessive material. Look for models with precision ground blades and adjustable guides for accurate material removal. Advanced options may also include interchangeable blades or variable depth settings for added versatility. Common mistake with a ridge reamer is just removing too much material or using the tool wrong. This can damage your cylinder walls. Follow the manufacturer's instructions, shave small amounts at a time, and check progress frequently. Proper alignment and even pressure are crucial to prevent damage. Next up, cylinder hone. It's available in ball or stone varieties. This tool deglazes cylinder walls and creates the crosshatch pattern that helps piston rings seat correctly. While it's a valuable addition, engines needing an overbore or high-performance honing are best left to a machine shop. A proper crosshatch distributes oil evenly, ensures ring break-in, and prevents leaks, reduces wear, and improves performance over time. Ball hones, priced between $20 and $50, are user-friendly and great for beginners. Stone hones, at $52 or more, provide greater precision and control, makes them ideal for high-performance applications. A good hone creates a consistent crosshatch without removing too much material. Look for adjustable grit sizes, ergonomic handles, and features like guide rails for even pressure and alignment. Be careful here, because over-honing can create taper in a cylinder, which is a common mistake. Avoid removing too much material by making quick passes and checking your progress often. Got to maintain the correct angle and pressure, and if you're unsure, consult a professional or follow a detailed guide. Next up is a freeze plug installer. This tool helps you drive plugs into your engine block without damage or misalignment. Now, it's not essential. A freeze plug installer makes installation smoother and more precise, especially when you're placing multiple plugs. You can also use a properly sized socket or leave the task to a machine shop if the engine's being prepped there. Freeze plugs or core plugs are leftover holes from the sand casting process used to create engine blocks. Though often called freeze plugs, their main purpose is to drain casting material, not to pop out during freezing. Manual freeze plug installers, priced between $10 and $25, are simple and pretty affordable. You place the plug in the tool and just tap it in with a hammer for straight, even installation. They make hydraulic models, which cost between $30 and $60, and they offer more controlled force for greater precision and reduced risk of damage. Installing a plug crooked is a pretty common issue, and it can lead to leaks. So double check your alignment and use steady taps to drive it in straight. Avoid excessive force, which can bend or crack the plug, or do like I'm going to do, which is just take it to the machine shop. Next up is a thread chaser kit. This tool cleans bolt holes before reassembly, removes debris that can cause false torque readings. While a tap and die set does work, taps are aggressive, and they might remove metal if they're used incorrectly. Basic thread chaser kits cost between $15 and $30 and include chasers for various size threads. Premium kits, priced between $35 and $60, offer high-quality materials, ergonomic handles, and even more size options for precise cleaning. Make sure to avoid cross-threading by properly aligning the chaser and apply even pressure. Take your time to prevent over-chasing, which can strip the threads and compromise their integrity. Like me, and you prefer not to invest in a kit, that's fine. A machine shop can usually handle this professional-grade thread cleaning. On a budget, taps from a tap and die set, like I said, can be used, but they require extra care to avoid damaging the threads. Finally on my list, we have an engine rotating tool. This tool lets you manually rotate an engine on a stand, making it easier to check clearances or install parts. Now, it's useful, but it's a little more optional, because you can usually rotate the engine with a socket on a crank snout or by turning the flywheel. Still, it offers better control to have the actual tool, especially for complex assemblies requiring precise movement. Manual rotating tools are priced between $20 and $50. They have a simple crank handle for smooth hand-powered rotation. Always make sure you remove your spark plugs before rotating a fully assembled engine. This is going to avoid compression issues that can make turning difficult or even risky. Apply steady controlled force and ensure the tool is securely attached to prevent slips or misalignment. Well, there you have it, guys. Those are the tools that I will be using to disassemble and then eventually reassemble my 351 Windsor engine. You know, when I started out doing this, I had no idea what most of these tools even were, and I had no idea what to even think about going out and getting or why you would use them. So I hope that this video has kind of shed some light on that for you, helped you out. Not only you guys may already be experienced engine builders, but hey, you know, if not and you learned something today, as always, I ask that you give me a like and subscribe. It really does help me out. If you have any questions, comments, concerns, gripes, internet ramblings, if I got something wrong, if you think I missed something, or if you think my importance factor was wrong on any of these, hey, give me a shout and let me know what you think in the comments. I appreciate that too. So as always, guys, thanks again so much for watching, and we will see you next time.
She's rough around the edges, but she's doing fine. Tinkering away, getting things to shine. At Bullnose Garage, she's considered divine.